So I'm Eric. I'm working with Jesse Hahn from Morph on customizing language models for code bases. And so as part of that, we do a lot of fine tuning. And I've gotten, hey, did you guys hear what I said? Okay. We've gotten in just a lot of cycles. We've done a lot of cycles of fine-tuning language models, and we've noticed quite a few bottlenecks in the workflow of doing that in the iteration loop. So the basic iteration loop of training a fine-tuning language model basically looks like you generate data, which might be slow. You fine-tune a model, which is fairly slow. By the way, at a previous hackathon, I experimented with how to do distributed fine-tuning of LoRA models on just commodity cloud instances, which you can get a big speed up from. But this hackathon, I focused on how can you generate samples for evaluation really quickly. It's a really simple sounding thing, but it's surprisingly difficult to do in a convenient way. So one example is, imagine you train a code model and you think it's going to be the best code model ever. And you want to evaluate on human eval. But human eval has 150 questions. And so if you only have one GPU, how long is it going to take you to generate samples for all of that? Especially if you're doing like passive 10 or something, it's going to take a long time. And then you notice, okay, something's just wrong with the model. The model's responses aren't quite right. So you go back to your data set, you notice an issue, but you kind of wasted an hour. So why is this slow? The reason is just that inference is surprisingly slow on like normal, like not super good GPUs. And most people are trying just fine-tuning with just like one GPU. And actually doing inference fast, especially on a larger evaluation set in bulk, requires multiple machines. But getting multiple machines, especially multiple GPU machines, is a big, big hassle. And also just like orchestrating the machines to do whatever. There are like endpoints to let you do like serverless inference, but those generally don't support LoRA or custom models very conveniently. So my hunch was, or kind of insight, is that LoRA is actually very cheap to distribute. So if you rely on LoRa's to do fine tuning, it should actually be possible to farm out a LoRA to a bunch of GPU instances or even CPU instances and run it in parallel at a large scale. So we prototyped this thing using a serverless platform, using a combination of GGML, llama.cpp to do inference of a fine-tuned code model on a CPU, and using Google Cloud Run, which can scale out a container image. And so the result is that you can have a very, very simple interface for running a LoRA fine-tune. And you just run it over a big list of things, and you get answers. And none of this is running in the Colab notebook. This is all running on a service we spun up using this Terraform and this little server right here, which just calls out the GGML. So it actually is as simple as that. Now, this took like 30 minutes to run because I didn't have enough Google Cloud Run quota. But if you actually have the quota to do this, you can run like literally all of these things in parallel. And so you can finish your evaluation very fast. Human eval in 5 minutes. I think a simple improvement is, it turns out CPU inference is still just kind of slow. Like you can't really do it in less than 5 minutes. But there should be a simple way to use something like replicate and use a GPU instance that you send LoRA weights to. And so that should let you do bulk inference on a custom model even faster.
Questions? Is this assumption here that the base model is already loaded onto those instances.
Exactly. Yeah. So much of the overhead comes from like loading the base model. So if the community comes to revolve around a small number of base models, then I think there could be a very valuable service that's based on this principle. That based on the principle of kind of using a single base model as kind of a fixed cost and just running LoRa's very cheaply.
At like what size models does this become like more valuable to keep it loaded? Because the models aren't that big to keep spinning up. And another kind of separate question is how does it compare with like spinning up multiple parallel CPU instances for evals versus like distributed on like spot rented multi GPU? Like if you go to like RunPod or anything and rent like a 4x like A5000 machine for like 2 hours and do distributed inference for your evals.
I think the answer to both your questions is similar, and the answer is basically like someone needs to figure out like how to maximize utilization. So with the size of the model, I think it's not the size of the model exactly that's important. It's whether the service is able to have the models be used at all times. Have the utilization be high enough not to have to like constantly spin things up, because that's where the overhead comes from. And then as for what you said with RunPod, that's kind of like one way that such a service could be implemented, right? Is on spot instances. So again, like how to manage that so that like you can get cheap spot instances while having that capacity and without like wasting money by having models loaded when they're not used. I think that's an interesting question, which I don't know the answer to, but I suspect like utilization is basically the question there.
Can you just like scroll to the top?
Yeah.
Cool.
Yeah, I guess my motivation for doing this is just like doing fine tuning a lot and feeling like why. So I used to be a front end engineer, and doing front end changes and the whole iteration cycle I just really fast. And so going from that to language model fine tuning, I was just like very
And like,
bored.
what size models are these that you're like comparing for the fine tune?
I'm doing 7 billion for this, but there's no reason in principle you couldn't do a larger model too. You just need slightly beefier instances. Debbie?
Sorry, dumb question. How does LoRA or not LoRA help with inference speed?
Yeah, because like imagine let's say you want to do an extreme version of this and you want like to do inference on 1,000 things in 1 minute. With a big model, like it takes a long time even just to send the weights, to upload the weights from your training server.
Isn't that a one-time upfront thing?
Not if you're like training multiple models. You're iterating on training models, right?
Got it. Okay.
Because every time you have a new model, it's going to be.
How much of that
models.
1 hour was loading weights?
Huh?
How much of the 1 hour was loading weights?
Oh, not much. But that's if you're doing just one GPU. If you have one GPU, then the 1 hour is just spent on doing inference.
Okay.
But if you want to do it on like 10 or 100 GPUs, if you don't use LoRa, then most of the time would just be spent loading the weights.
And does any of this transfer to like if we want to run like a real inference server? Can we use CPU, or is this just specific to your offline use case?
Yeah, I think you can't really use CPU for like unless you really use a lot of CPUs. It's hard to do it for like an actual like service for users because the latency is too high. But for this kind of evaluation, you can wait like a couple minutes for each
Or
thing.
other offline things like tagging or classification.
Yeah, you can use CPUs.
Yeah. Sick.
Yes.
Awesome.
Slightly unrelated, but why don't you use LoRa versus standard fine tuning based on your experience with the models?
Yeah. So I think based on Robert from Anyscale also alluded to this. I think like LoRa is generally similar to performance to full fine tuning, except for situations where you have a ton of data. And I actually haven't really. My work has just been in situations where I only have a moderate amount of data, so I haven't had to do full fine tuning.
And
I think
what number of data points is that?
Like a couple hundred to a couple thousand, I think is fine for LoRa.
But if you had 10,000 or more, you would.
Yeah, I guess I haven't tested that yet.
It's
Although
all
I will
balance.
say though that like, I think LoRa can be valuable even if you may need to do full fine tuning in the end, because doing LoRa lets you iterate fast, And so the key like determinant of your final model performance is the quality of your data set. So as long as your fine-tuned models give you good enough like feedback for you to continue to improve your data set, then I think it can be valuable to do LoRA even then.
Awesome. Crowd work.
All right. I built a coding agent for essentially Kaggle environments. I am sort of in love with Kaggle environments as a training ground for interactive coding, especially for data science. So first, what I built, this is basically like a little code interpreter that works natively inside of Jupyter notebooks in Kaggle environments. So the idea is if there is a Kaggle notebook somewhere that can be run on Kaggle, it can be run in this environment. And this agent can make changes to a notebook, it can create a notebook, it could manipulate a data set that you download from Kaggle and find some insights for you. And also, very interestingly for me, it could generate fine-tuning data for chain of thought reasoning on small models. So just a little demo of what this is. Here's our agent, we're gonna run it. We are running a Kaggle Docker image or Docker container. So I'm gonna ask this to do something really simple and we'll just watch what it does in this notebook. Okay, so it's asking me to paste some Kaggle download code. I'm not gonna import anything, I'm just gonna show you right now what this does on its own. So what should I do? Show me NumPy A range. And then this is thinking of what to write in the notebook. And we'll see very slowly, because I haven't added streaming output. Oh, we'll see it wrote something. And now it's running its notebook so that we can see its output. That'll take a couple seconds because these environments are ridiculously slow. Oh great, we got an output. So it looks like A range gives us NumPy array from 0 to 11 exclusive. So so then we can do lots of other things, right? We can go really ambitious. We could ask this to, let's say, train an MNIST classifier. Train. And then it will chug away. Now this agent, it works reactively. So it writes code, it can edit code that it's written before, it can read error messages as they pop out. And the idea is that it takes a goal, it tries to achieve it that you specify, and it will write the code wrong. It'll make errors, it will reference variables that don't exist, then it will have errors contained within this notebook when it runs it. And it will correct those one by one. And then eventually you will have something that looks like what you asked for. Now, while this runs, because it's ridiculously slow, I will show you what my dream is for what this will become. So right now I'm taking a notebook on basically nothing and asking it to create something. But I could also have taken a notebook on any one of thousands, I think it's tens of thousands or hundreds of thousands of public notebooks. And then I could have, like an example of this is a very popular beginner data set, Weedle's Cave. So you see they're doing a bunch of exploratory analysis, they're trying to take some statistics. And it's very interesting to me to make interactive llama to do reasoning in chain of thought. So one way we could make this is we invoke a chaos GPT. And this chaos GPT, it just sort of wants to ruin your day. I've told it, you are a Jupyter sabotager. You have been asked to introduce bugs into a Jupyter notebook. These bugs should preferably lead to errors later on in the notebook. So the dream here, and I cannot show you chaos GPT because I haven't set up the Kaggle data downloads, is it can create these errors and then you put this normal Kaggle agent to the rescue. and we will watch this Kaggle agent try to fix these bugs and run the code without errors. And then when it succeeds, we add this to a data set of successful chain of thoughts. And then we can have this for real live environments that are representative of actual data science scenarios. And we can feed that to Llama, and hopefully that's a fantastic data set. Let's check up on how our model is doing. Oh, it's running the notebook. Yeah, sorry about this. Okay, in this case, no news is good news, because Jupyter notebooks in this very hacky, through a container scenario, they don't give you their output until they're done. So I'm going to actually make it cause an error. I'm going to Control-C, keyboard interrupt. Let's see if this, hopefully this shows us. No, it seems like, okay, anyway, no news is good news. This was running, even if you couldn't see it, I promise. The idea is with better output, you can make an automated data set at a very large scale.
Here's what the VS Code code review is. That's really cool.
Oh, this is jellyfish.
Worked at a company where that was a mascot.
What kind of model did it try to run on MNIST? Why did it, is it taking long? You said it's going to take long in this environment. Is that just like a byproduct of what you have, or did it just try to run a huge model?
Well, let me tell you about this environment. This environment is my computer. There's no GPU on this. This is this is running in some environment with it has no GPU access. This specific, the code I use to run Jupyter notebooks is doing a double layer export. It's running it inside of a second process. It's really slow. It's sort of the biggest problem I have to deal with. So what does this model look like? It's just sort of like a 4-layer MLP.
Will this model be able to compete on Kaggle?
Probably not. It's probably going to be pretty crappy.
So one of the most aggravating parts about Kaggle is just loading the data. As if you figure out how to do that for kind of the more complex data sets, or do you think it would be able to?
Okay. First, no. The part that I can download from Kaggle is just the people's notebooks that they've made. I think there are enough notebooks on Kaggle, public notebooks, that I can just throw away the ones where the default Kaggle CLI download fails. And there will still be enough left to be a good training data set for reasoning. All right, thank you.
This is awesome.
Hello. Okay. All right. So let me preface this with I just wanted to make a little silly project today, just something for fun to make me smile. So the project is called Riz Eval. The premise is that so I fine-tuned GPT 3.5 Turbo on my iMessages so that it would try to text like me, and I couldn't convince my friend to give me his texts. So the other model is just raw GPT 3.5 with a prompt. And so the premise of the project is the two models have a conversation with another instructed GPT 3.5 instance. And at the end, another GPT 3.5 instance is called to determine who has better Riz. So that's the nature of the project. I can try running it for you. It'll take a little bit. The first one that runs is what's fine-tuned on me. It's not perfect. It only had 3 epochs, and the data was not perfect. As you can see, there's the /u or whatever, not parsed out. And yeah, it's pretty sterile. I'm pretty sure it's because of the guardrails. And then yeah, the other one's pretty funny, I think. I prompted it to be really bad at talking to people, and so it says and a lot of filler words. Yeah, and then at the end you'll see the evaluation. Yeah, and at the end, the conversation one is better. Go me. Yeah, that's the nature of the project. That's it.
Questions about
How did you fine tune the messages? Did you just download your folder?
Yeah. So the weird thing about it is Apple makes it really hard to get your data, and so the only way that this could actually be shipped as a consumer application is through the desktop. So you need to like make a desktop app. They download it. But thankfully, there was someone that already built like an open source package called the iMessage exporter. And so all I had to do is like run a command from the terminal, and then I got the data. So it's pretty easy.
How similar to your actual texting style do you think the fine-tune model was?
So the first text is pretty similar because it's just like, yo, like what's up, or like like hey, what's good, or something. But I think for anything after, no. I'm not sure if that's because it hasn't trained enough. But yeah, it's my first time fine-tuning one of these models, so. Anyone else? No? Cool.
So we made the embeddings playground. Our thinking was before ChatGPT came around, we didn't actually build with AI at all. It was the launch of ChatGPT making it like way easier that made people realize what is possible and thus like start to build. And for us, one thing that we think is like really interesting, but there's really not that many good tools for, is embeddings. And so we decided to build the embedding playground.
Yeah. So I'll give a quick demo. Yeah, we work on like code gen tools on the side. So part of today was like testing our tools and seeing like making sure they actually work before we launch. So yeah, so go ahead and just give a quick demo. So it's actually kind of hard to hold in here. How did you guys do? I'll just talk very loud. It's like it's pretty close. Okay. So so I come over here. So I'm just gonna like paste a list, some kind of basic stuff here. I can say like fruit over here. So obviously here you're gonna see it like all chunked together. That's not probably the most useful way. So I can come up here and just describe like the chunking method that I want. So in this case, I'm gonna say like new line and like 30 max or something. And so that'll change like how that all gets sorted, broken up into, so you can see the weights here, nothing too crazy. I can also like switch between models here. BG's sometimes works for us, but the API we're using kind of is, we keep blowing through our credits for it, so not today. But yeah, so so that's like one example. Let's say some other text has some boom. Like yeah, you can do like again, you can do like an essay and change this to like. There's also like a control you can change here, so you can see what that would look like with like 100. And so it's just like a nice way to be able to say like to be able to like just iterate on embeddings. So yeah, and then like, there's also like this like view code thing. So depending on how like kind of what settings you end up with, you can just copy this code and paste it to your app, which is pretty cool. So yeah, that's pretty much it. Cool. Any questions? Yeah.
What's the search bar for? Like you said,
Oh.
it's new line and 30 max, but there's also
Yeah. So
chunk
these
line?
are also here. Yeah. So we wanted to have it like be like a little bit more generative, where you could like split based off. For example, if you have code in, you could say like chunk it based off like functions, paragraphs. So we got like some of it in, but it was like structured to the point for like where it was not as like here is what we're talking about.
This is pretty. What is your phone?
Oh, it's just React. I was a designer for a few years.
What are your secrets?
What did you learn about embeddings?
Yeah, so first of all, we learned that like BG is way better than ADA, because like when the last time we used when we were first using embeddings, like we were mainly using ADA. We've been using BG a lot more recently for our projects, for like our CodeGen project. But yeah, like it's just like way more obvious when you're seeing it here. I wonder if like if I refresh, it's just we keep the API we're using. Let's see if we can get it. But it becomes really obvious, like. Okay, so this is what you're looking at. So yeah, we just keep going through them. But oh yeah, so like orange here, like it's like okay, yeah, it's like related to like fruits mostly, and you see like lion is like down here. I don't know why dolphin. Well, dolphin and lion are like pretty much equivalent in this case. Like, but carrot. I don't know why penguin's higher than lion, whatever. But so it's like some interesting things, right? But if I change it to actually this did like a little bit better.
Tiger's up there.
But yeah, tiger is like really far up into like I type the G or like whatever. So and there's like weird qualities like that. But yeah, Ada's just like much worse. It's like you get it a lot more as you're playing with like different examples. Yep.
What problem were you trying to solve?
Yeah, so mainly like we do a lot of like we use like playgrounds, for example, OpenAI playgrounds a lot to prototype. Even though we have it like all built into our app, it's like a lot of times it's just nice to be able to iterate on prompts faster. And so we haven't seen a good way to be able to iterate on embeddings as easily. Like sure, yeah, you can just like do it in Python, it's fine, but it's just like if you're just trying to and then for example, just having like nice control over how you're chunking and different types of data. Like, are you trying to categorize like different sorts of questions? Or are you trying to like find specific parts in like a code thing, like a piece of code? Yeah, being able to compare different models as well, super helpful because different embedding models have different like strengths and weaknesses in different areas. So yeah.
I really like the inspiration of creating a playground, just like how ChatGPT created a playground for LLMs, doing it with embeddings. The thing that's unclear to me is like there's like embedding visualizers out there like Nomic for doing those embedding spaces and whatnot. What inspired the decision to choose this like strictly text-based visualization as opposed to something more spatial like that?
Totally. I think it's kind of like what Zubin was saying, where it's like I think people, this is kind of like the probably like low and maybe also the other end of the IQ bell curve or something, where it's just like you just type in stuff and you see it, right? But like ChatGPT is like somewhat similar, where it's like you have like very like little control, especially early on, like of like what's happening. Like you can't set the temperature, you can't like, so it's like yes, if you had more control, like you can get much better results. But it's just like just at a very base level. For example, like being able to like just like have very like easy control over chunking. Like again, like I have like a design background, like well, not originally, but most recently. And so just being able to like iterate quickly on it is nice. I would love to have like more visualizations and stuff like that. Like it'd be super cool if you could just do like different projections in like 3D or something, or different image stuff.
Part of it is like what you can create in the constraints of a hackathon.
Yeah.
That's true.
So this is all in Hack.
Yes.
Yes.
Emphatic.
But made with Sidekick, which is coming out. Okay, so-
You can see our commit history.
You're allowed to write the code that writes the code.
What?
Are you allowed to write the code that writes the code? Yeah.
Yeah, exactly.
That is the existential
Writes the
question.
code,
Or
writes
fact in
the
that case,
code.
yeah. Cool.
Okay.
Yeah. I talked with some of you earlier today, and I had the idea of basically something like like a lot of projects do code generation for projects, like small, for example, and just having a template to kickstart your project can be sometimes super helpful. So let's run that command. I worked on it from dinner onwards, so it's very new. But let's see how this goes. So basically the idea is it will create a new repository, and it will use a template that I'll show later on GitHub if I have time. But basically you see that here it created the Python template, and then it bootstraps the project to replace the files in place, and then hopefully it's going to create, so here I should have probably started there, which is basically you specify three things. I use the AnyScale endpoint that we were provided with, and just like the input would be just this objective. So here it's just create code to download data, train a machine learning model based on Iris dataset, and then put an API in front of it to respond to post requests with the predictions from the model. So a very simple case, right? So yeah, let's see how this went. I think it just didn't update this, so I'll just reload. Yeah, it's hard with the mic. That's true. So let's see. I think this one is stuck, but maybe if we look on the repository. So this one is the actual repository, and then it should have created right now a generated code and created a pull request with the code that we want. So this should have been pushed in the last minute, hopefully. Yeah, so we see here add generated code. So we see that here it created two files, one to train, one to predict. So something very easy, but then you get all the benefits of having all your code structure from like the Python template. So that means you'll get, like, for example, this repo is kind of an opinionated way of structuring your project with pre-commit and semantic release and the GitHub workflows and stuff like this. So it's basically an enhanced way of setting up a repo from a template. Any question?
So are you familiar with cookie cutter?
Yes.
So you would say this is like maybe like a natural extension of that, like cookie
It's
cutter
kind
instead
of, yeah. Cookie cutter, I haven't used it in a long time, but cookie cutter, if I remember correctly, is based on like only your code structure. So it would like generate like your SRC folder or something along these lines. So here it's a little bit like this, but I can actually show you the Python template. So this comes from this repo, so it has, I don't know if you're familiar with a few of these things, but like usually this way it's like an opinionated way as well. As I put it, I don't know why it's zoomed in like this, but you can see that like usually you want to have like your code semantically released with like semantic commit lint. You want to have like your pre-commit checks, which, for example, like lint your code. So you see here it uses flake8 and isort and like all the things that Python would use. So it's kind of a cookie cutter, but it's also all the setup that you would have for like a language-based project. So here it's like all the best practices that you would have for writing Python code. You put it in a template on GitHub, and then you bootstrap your project from that. So it's not only related to your code, but actually like your lint test build, as opposed to cookie cutter.
Which files is the agent aware of when it's writing, when it's adding code to a repository?
So right now, because it's like I just like spent a couple hours on it, it just like looks at the core folder. So if you go back to the other repo, it's only gonna create the files, like the only files it modifies here. And you see, like, for example here, lint fails, but the only files it modifies are gonna be within that the same name as the repo. Replace minus with underscores, and that's it. So right now it's only focused on like the equivalent of the SRC folder basically, and all the other files are going to be generated and kind of standard, and like your GitHub workflows and your release rc.json and all the stuff that you need to like release, lint, test your code. So ideally, I think the next step would be to also include like tests in like a test folder or something like this, but it's like it's only gonna write files in like the equivalent of like the SRC folder and the test folder.
Is it aware of other files? Like, do other files get passed in the context?
Right now, no, but that would be great.
Oh, okay.
Good point. Take it away.
Yeah, so I know, thanks everyone for being so patient with a lot of presentations. I'll try to take as long as I can, but no. So real quick, like basically, I just had this idea of like what would happen if I described a bug, and then I let agents loose on our whole production repo set, and they just basically read all the code, and they figure out where they think the bugs are coming from, and then they just start pushing out a bunch of PRs to try and fix the bugs, like interns would if you're just onboarding like a huge group of them. And so it was kind of like I didn't really know how far it would get, and I learned a lot along the way. So I'd honestly love to just like I could answer questions, I could show the code, but I mean you guys have gotten a lot of that. It was a fun journey. I think somebody had mentioned trying to do the higher context window llama. So I had gone down a rabbit hole for a few hours of the day trying to get llama 128K context window with yarn. The yarn method for extending the context. It was basically like a systems hell trying to get that working. And then I started realizing that like you can't just ingest massive files, because now you need to start bunching these up by functions and then repositories. You need to be caching things. So I could jump into the code here and like kind of show high level, but honestly, I think the easiest thing to do is just like, I'll give like 20 seconds of like, here's the top level flow, and I'll answer any questions people have. How far I got was I basically either have some debug flags of like repos, or I'll scan our actual production repos. I don't want to run that right now because it would reveal all of Banana's IP. So, but it does work. And then what it does is I can just show the code right here too. Where is it? Here. Sorry, that's a different. Here, this is a different repo. Let me clear that. It's our God repo. Yeah, so this is why I don't do stuff in prod. Okay, let me just stay here and look at the code, because I don't want to. we have this like admin repo that if I run it wrong, it'll nuke prod, so I don't want to do that. Basically, it'll scan all the Git repos, and then it'll pass in all of them to GPT-4, and it'll open like a conversation, and it'll start having this like discussion about like, hey, here's a bug description and a repository name. Can you help determine if it's likely that the bug would be in this? And so what we did was, most people, when they try to solve this problem, they actually scan the code first. And so I tried this, but then it leads to this explosive problem of like there's tens of thousands of lines of code. If you scan the readmes of the repos first, they explain enough about what the code does that you can use that as an approximation, and readmes are typically short, so did that. I guess one final thing I'll say is, I didn't get to the generating pull request yet, but I realized that one of my friends, Kirtana, at a previous hackathon at AGI House, did SweetPT, which is like the software. They basically generated pull requests, so I'm going to wire that in next. And then, yeah, basically, we have everything. That's all. Any questions? Intern deploy. Thank you.
Cool. Okay, give yourselves a huge round of applause.